Hello guys, in this video we are going to discuss the solution of the problem segregate zeros and ones. So let us look at the problem statement. The problem statement says that given an array ARR consisting of only zeros and one in random order, modify the array in place to segregate zeros onto left side and ones onto the right side of the array. So for instance, if this is the array which is given to us, so as we can see there are three zeros, so the three zeros will come towards left and the two ones will come towards right of the array. So that's about the problem statement, folks. Now let us see how we will be able to solve this problem. So the solution of this problem is rather simple. We will take two pointers I and j, and we are going to set I equals to 0 and j equals to len of ARR minus 1. Now we are going to iterate on I and j while I is less than j. So here I represent left part of the array and j represent right part of the array. Now if ARR I equals to 1, then that simply means on left part of the array we are observing 1. Now since as per our question the left part has to be 0, because of which this 1 we are going to send it to the right part. So let us see how we are going to send it to the right part. So we are going to find out the appropriate location where the I has to be transferred to. So we will have a findj function, and to this findj function we are going to pass array ARR I and jth pointer. This findj function will return the index of jth position whose value is 0. Now we are going to check if j is less than 0 or j is less than or equals to I. In such case, there isn't exist any j place where I can be swapped to, because of which the array has already been arranged in the manner because of which we will go ahead and break our loop. Otherwise, the jth position is there with us, so we can just simply go ahead and say ARR I equals to 0 and ARR j equals to 1. And then we are going to update our ith and jth pointer. So the I will be increased by 1 and j will be decreased by 1. If ARR I is not equals to 1, then that simply means ARR I equals to 0. In such case, we will just proceed to the next element, which is I plus equals to 1. And in this way, we will be able to arrange zeros and ones in the array. Now let us look at the findj function. So let us define this findj function. Array is there, I and j pointers are there with us. Now we are going to iterate on j while j is greater than I and ARR j equals to 1. So we just want to find out the first position where ARR j equals to 0. So that is the condition for that, and we will go ahead and decrement our pointer, and then towards the end we can return j, and in this way we will be able to find the j pointer. So that's the entire code, folks. Now let us do a quick dry run. So there isn't any issue with this code. Now let us submit our solution. So our solution got accepted. Now let us look at the C++ implementation of the same problem. So the same logic, folks. I equals to 0 and j equals to n minus 1, which is length of array minus 1. And we are iterating on I and j. Remember, I represents the left half of the array and j represents the right half of the array. So essentially, all i's should be 0 and all j's should be 1. Now we are iterating on array while I is less than j. If ith position equals to 1, then that simply means this ith position has to change to 0, because of which we are finding the first j, which is 0, and then we are changing the value of ith and jth pointer. And then we are updating the values of ARR I and ARR j. After that, we are updating our ith and jth pointer. In between, this is a break condition, which simply means that all I and j has been sorted accordingly, because of which this condition will be satisfied, and in such case, we are going to break from the loop. So that's the C++ code, folks. Now let us submit our solution. So our C++ solution got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.